how are you doing? Good? Okay, so far, our previous lecture, anybody has got any questions on that? What we have been doing, the one that we did yesterday, the parallel lines, 3 or more parallel lines, and transversal, and they intersect and they are proportional, right? So you had 1 or 2 problems from there to complete, right? Are you guys good with that?
Yeah.
Anybody, any questions? Any questions?
Yep.
Any questions? Yes.
Are they going to be proofs, or are we just going to like show?
Yeah, I mean, that proof I'm not considering. That you'll have to do the problems. You'll have to solve the problems. And once we go for the test, I'll give you the complete review questions, a set of questions, like sample 10 to 15 questions, and we'll have 5 questions, 2 proofs and other.
So will the questions be similar to how they are?
I mean,
for
the way
homework?
you did the
Like
mathematics,
the way
the
it's
class
done, the
one.
homework,
Yeah,
where they're
yeah.
like we're given information
Yes.
that's not in proof.
Yes.
Okay.
And I'll give you complete idea once we go for the test. And I have declared that on the second one, yes.
Like one sheet where you're that like it was like that like 2-day lesson where you're like, oh, they don't have names of the properties or whatever. Are we gonna be testing on that?
Everything that we have covered similarly, right? Proportional, similarity, and all those theorems, right? Good? Okay? Okay, so now today we are going to learn a very important theorem, and you'll have to will together write the proof, okay? So let's move on. That this is the theorem 67 from your text, and it says angle bisector theorem. Somebody read it for me? Yes.
If a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides.
Adjacent sides, right? So it tells that a ray bisects. So here you see that bisects an angle of a triangle. So there is the triangle ABD, and which one is the ray that bisects an angle? Here, yes.
Can you scroll up?
Oh, you wanted to read that?
Yes.
Okay, everybody read that. If a ray bisects an angle of a triangle, divides the opposite side into segments that are proportional to the adjacent sides. Okay? So we'll translate it and we'll go for the proof. If you look at the figure, there is a triangle ABD, right?
Sorry,
Yeah.
can you zoom back out a little? Yeah.
Oh, you want to write it?
Yeah.
Okay, write it, complete it. I thought it's there in your text. Understanding is the main key. So, we're good?
No.
Okay?
Wait. Sorry. Are proportional to adjacent sides. Thank you.
Good? If a ray bisects an angle, so look at that. Of a triangle. So what is the triangle over here? Anybody? What is the name of the triangle we have in the screen? Yes. AB, D. So that angle bisects triangle, it divides the opposite side into segments. So in triangle ABD, AC is the bisector, right? Angle bisector. And that bisects which angle? Yes. BA. Now we'll have to prove that it divides the opposite side. The opposite side is BD, right? Okay? Right? So what are the segments over there? It divides BD into 2 segments. So what are the segments? Who can help me? So their ratio is BC over CD, right? And it will be proportional to the adjacent. So which one is adjacent to BD? BC?
AB.
AB. And which one is adjacent to CD? Yes. AD, right? So this BC over CD and AB and AD, if they're equal, we can tell that they're proportional, right? Good? Give me a thumbs up. Okay, great. So now we'll have to write the proof for that. Who wants to try that? Anybody wants to try that? So let me draw that. If it is like this, we said this is A, this is B, this is D, and this angle bisector, that's what we named as C, right? So in this triangle, ABD, we can see that what is given, right? So from here we'll move on, we'll have to prove BC over CD, adjacent of BC is AB, dash over what? Which one should be? AD. So to prove that, what we should do? Now our challenge is, so far we have been proving from two different triangles, right? Now this is the same triangle. So any idea, any big idea? Yes.
So are we given anything here?
Mhm.
Are we given anything? Or is it just
Yeah, we are given that
Yeah, we're given the angle.
ABD is a triangle. You can easily say that is given, right? And then what we can say, the ray AC bisects angle, which one? Yes. Okay.
Oh, angle A.
Angle A. So it's better to say BAD or angle A. Okay, fine. I would say BAD. So given, right? These two are given. Yes.
so you can maybe like, whoa, okay. It doesn't bisect like angle C, right? So it's just AB.
So this guy and this guy, you want to say?
I was saying it can't bisect the body too, right?
It might, or let's say if the situation is like this, okay? Right? There is still congruent, but are they congruent? No. So can they bisect? It's not always true, right? Good? Okay. So our theme has to be based on this guy, right? Yes.
Would you do like AC is the bridge AC X?
I mean, let's say first, the moment we said that it's a triangle, right? It's a triangle. And once it's a AC bisects BAD, what's the conclusion? From there, where can we move? It bisects this. So if we name these two angles, can we move somewhere? Yes.
Was it with like the two, like ABC and like C?
Yeah. So we say, what we can say from here? Conclusion we can take. Yes.
Angle lines are congruent.
Yeah. So angle 1 is congruent to angle 2. That's what we can tell, right? So why we say that? The reason? Somebody from that corner? Kayla, you want to try?
Angle bisectors divide angles into
Array bisects or angle bisectors. Yeah, that's a good way of saying angle bisector divides the angle into two congruent angles, right? That's what you can tell. Yes.
Would you allow like this definition of angle bisector?
Yep. Definition of angle bisector. That good and a smart way. Less writing and better way, right? As long as you know that. Good, everybody. So, Sally, any big idea?
I was thinking how we could say AC is congruent to AC, which is what you had said, and so
AC is congruent to AC for which reason? What is the reason?
reflexive property.
Reflexive property. Okay, fine. If we say AC is congruent to AC, I'm writing it little for reflexive. Fine. So where do we move from here? Anything with AC here? I understand that you're trying to prove that both of them are congruent, then probably if we can move on, right? Right? think about your previous rules or previous theorem that we have run. Yes.
Like, maybe you can, like, if you have angle A is reflexive, right, so it's congruent to angle A, you have, like, side BA. Like, I was thinking you can, like, prove overlapping triangles congruent first.
First thing we'll have to go for proportion, right?
Yeah.
But BCCD, right? BCCD and ABAD, right? This AB and this AD, right? These guys. So if it is proportion, can we think about any theorem that we have learned? Similarly, that one we have learned few, right? What about that? Can you guys think about side splitter theorem? If we just little, what is that? Who can tell me the side splitter theorem? What does it tell? Yes.
If a line is parallel to one side of a triangle and it intersects the other two sides, divide those two sides.
Yeah, if a line is parallel to any, let's say A, B, C, D, E, if these two guys are parallel, okay, intersects parallel to one side, intersects the other two sides, then these guys, right? AD over BD or BD over AD equals SE. What?
So your phone is ringing?
Oh, I'm sorry, it might be.
Should I hang up on it?
Just cut it. Okay. Probably, I don't know. My mother was probably calling me. Okay, I'm sorry about it. SECE. Okay? SECE, right? So if these two, can we think something like here? Yes.
You could draw a line parallel to AC, extending
Parallel
from
to AC.
extending from B.
Yeah. Looks good. You guys think that? That's probably can give us something parallel, right? Right? So then I have to get there, right? Parallel, so I have to extend this guy, right?
Wait, why?
I mean you're extending this just to make it parallel, right? What's your objective?
I don't really know. It just.
But you got the great idea, right? Yes.
Well, if they're parallel, that means that BC is proportional to C.
Yeah, if we can make it a parallel, then you got the idea that we can say these two lines are parallel, and then probably we can say this guy over this guy over this guy, right? Right? Yes.
Okay, but when you're like doing the actual proof, right? What would you do? Like,
Yes, you'll do so many things, not only in geometry, in algebra, and everywhere. You'll be bringing something. This is this. Then probably we can move on from this. You'll be assuming so many logical things. Is it logical if we draw something parallel and get into this shape and use this side split up theorem? Is it logical? Can we do that?
I'm not saying it's illogical. I'm just saying like when like writing like statement reason, what you put the reason as.
Yeah, that's what I'll be saying. Then 4 will say, let's extend.
I think I have something prepared up there. For the right language, I want to give you the right language, right?
So you can write, draw through B the line that is parallel to AC, right? So what you can do is, what we did, guys, let's name it something like, what do we name it?
Creation property?
Let's say once we extend it, right? So, take a deep breath. Yes.
What would we call like this like
Yeah, that's what I'm going. But we have done the job, right? So what we say is that draw. We are doing something like we have drawn here with me on the board. All right, guys. So what we have done to use the side splitter, we have tried to make two parallel lines into one triangle. So we say draw through which point we draw? We have drawn this line through which point? from B. Are you guys getting me?
Yeah.
So what we have done, we have drawn a line parallel to AC through B, right? So we are just writing it, okay? So we are writing that we are telling that draw through B the line that is parallel to which one? Parallel to
AC.
AC, right? AC, okay? So now, why? So we can say that this is a parallel. What is the name of these rules? In geometry, what do you call them? Postulate, right? This is a parallel postulate. We have drawn a line which is parallel to this, right? Yes.
Would you also have to specify that you extended line A to C?
Yeah, that we are coming, yes. That whatever we do, whatever extra drawing we do, we'll have to write everything in our proof. And find the reason to make it logical, yes.
What is like the actual like definition of parallel postulate?
Parallel postulate is if you draw Ms. Moore, can you please give the explanation to her?
You can, parallel to me, that is, you can draw any line parallel to any other line.
Yeah, that's simple. Okay? It's that simple, okay? In mathematics, sometimes we think something is too difficult, but it's so simple. Alright guys, good? So then what do you do? We
Any two points create a line.
I would be lenient with the reasoning here.
Good? I'm trying to give you everything in detail so that you understand. But while writing, you can avoid few of the things, right? And we'll tell. Okay. So next, what we did, we extended this DA to meet with this line, right? Right? So we write that. So we say extend. I'm erasing them. I'm going little up. Everybody good up to this, right? Guys, give me a thumbs up. Cool? Okay. So we say extend. That is 5. Extend DA to intersect. Intersect which line? DA to intersect which line? Guys? Intersect. Still we didn't name them, so we say intersect the parallel line at some point. We named it E, so at some point E, right? So we have extended DA, keep going, but the point where it meet it, right? So you write, yes.
Is it necessary to write that law out? Like, sorry, not law. Is it necessary to write that statement out?
I mean,
Not that necessary once you write, because I understand, right? You teach it, right? So I'm just explaining how you should properly write, but if you don't write that, I don't mind, but this is the way it works. So I told you that once I'm from this side, I'll have to go on with that students who might struggle, right? So if you write nicely, then lately it is a reference. But during exam, if you don't write this, drawing things, we don't mind, right?
you know, it depends on what kind of proof you're gonna put on the exam. This is a proof of a theorem, so this
Theorem.
involves more, you know, that when you use the theorem, it's different.
Got it? Good? Good? Okay. So now, if it happens now, so what we can tell? So this is what we can say. A line can be expanded as far as a line can be. This is why I did it, because a line can be extended as far as desired. Okay? So these are just the reasons that I'm telling you that, well, you can write this way, but this is the reason why we do that, and we can do that. Okay? Make sense? Now, okay, let me come to this side then. So now, are you in a position to write down or conclude anything from here towards your proof? Guys? Now we have a triangle where, forget about this, this line is parallel to one of the sides and intersect these two, right? Yes.
So you should just say, BC over CD.
BC over CD,
Is equal to EA over AD.
EA over AD, right? Can you say that, guys? Can you say that? What is the reason? Yes, the side axle and side splitter. We are almost there, right? Theorem. Okay. So once we are there, we are almost there. All that you see, it looks like this. It looks like this. Only thing is, this guy and this guy. If we can prove that they are congruent, then we can substitute, right? Right? Who can do that? Yes.
Okay, so angle EBA is congruent to angle 1.
So let's name it as 3.
Yeah, alternate interior angles, right?
So
Because
1 and 3 is congruent, right?
yeah.
If you want to say that, so we can say that.
And then angle E is congruent to angle 2 by corresponding.
So this the reason is
So that's alternate interior.
parallel lines create
Alternate interior.
alternate angle.
And then
Alternate angles. Okay, then
angle E is congruent to angle 2 because parallel lines.
let's name it 4.
Alright, so angle 4 is congruent to angle 2. Because
You guys agree?
Wait, why is they congruent to
So yes, let's go slowly.
3 is not congruent to 4, although I guess it is. 'cause it's reciprocal.
2, this parallel, right?
Yeah.
Yeah, but
Okay.
how did 4 like
If I name it 4, what's your question?
Oh, sorry, never mind.
You got it?
Yeah.
So you know this. Think about that one. This guy is congruent to this. Why?
Corresponding.
Corresponding. Okay, no problem. So 2 and 4 are equal because parallel lines create corresponding angles, right?
So,
Okay.
Yeah.
So now, anything? Yes.
Yeah, so I think you can say that angle EBD is congruent to ABE because of AA. Or sorry, EBA is.
So 1 and 3, 2 and 4. At the big, yeah.
You can say that, since angle 1 and 2 are congruent.
Yes, in the beginning we were given that bisector angle 1 and 2, right? So since 1 and 2, can we tell that 2 is 4, 1 is 3, so 3 is congruent to 4? Can we tell that? So what is the reason? Yes, anybody? Somebody said why? Yes. Substitution? Why? But why you could say 1 is congruent to 2 and 2 is congruent to 4 and 1 is congruent to 3. A is B and then again A is C. So A equals C, right? Transitive property of equality, right?
Isn't it?
Make sense?
Substitution.
Yeah, substitution. Yeah, substitution. Yes. Oh. Oh, probably. I'm probably little confused for my professor, right? Okay. So in 10 now, we can say that what we can tell.
I have a question.
Yes.
What's triangles? Like, what are we doing exactly with all these angles?
We are trying to prove this, right?
Right, but what's triangles are we using?
No, so you're
Okay.
like a proportion, so what's you isosceles and prove the angle of the lines, and then you use substitution.
What are we trying to get to and how is?
I mean, are you guys okay up to this?
I get why everything works and why everything is true. Like,
Why are we doing
what
it?
if, yeah, but what, how is this gonna lead us to the?
I mean, are you guys okay up to 6? I'm coming.
Yeah.
I'm answering. Are you guys good up to 6? You are good up to 6?
Yeah.
Now, you see, we are trying to prove this, right?
Yeah.
So, we have this element here, this element, this segment here, and this is here. Now, you can somehow prove EA is congruent to AB. We can substitute, right? Right? Yes. Yes. Right? Good? So we are trying to prove that EA is congruent to AB, right? So once we say that 3 is congruent to 4, you are good up to this? Okay? So we can say this AE is congruent to AB, right? So we can say EA is congruent to AB. Why? Because triangle side opposite to the congruent angles, sides are also congruent, okay? Right? Side opposite to the congruent angles are also congruent or equal, right? So once we see that, now can we replace this guy with this by substitute that? Can we do that? So now we are saying, I'm just reading it here and I'm saying that 11 as BC over CD is equal to EA is substituted by AB over this AD, right? Substitution and just give the number from 6 and 10, right? Yes.
Well, you want us to like put numbers on the test? Because like we haven't been doing numbers. Like indicate where we got.
Yeah. Just say that. That will prove why you are telling them. Yes. Yeah, sure. Everybody good? Yes.
What is the theorem called where you have two parallel lines and then like the smallest one forms the midpoint or something like that?
Yeah, that is it goes to the midpoint, then there bisects that. I mean the parallel line is half.
But what's that theorem called?
That is called the median theorem, right? No, not median. That's called. I mean, they're talking about that one. Once
The midpoint was just an example. That's the side.
you're talking about that in the midpoint,
It's not a theorem.
A, B, C. If it is the midpoint, right? Then this DE is half of BC, right? That rule you were talking?
Yeah.
Yeah? Okay. That rule, we call that? It doesn't have any specific name so far I remember, okay? But we are using the side splitter theorem over here. You got that?
Yes.
Okay guys? Good? Now this proof is written nicely in your text. So if you go over that, you'll be good. Right? Good? Give me a thumbs up. Okay? Listen, I wanted to write and get you used to with writing proofs because that's an excellent way of learning mathematics, and especially geometry is the one where we apply our algebra knowledge to see the reality in logic, right? So to recap and sum up, basically what happens if we have a triangle where an angle is bisected by a ray, and then the segments it creates, let's say this is E or let's say this is D, okay? So BD, this segment, this one, over CD or DC, okay? E is proportional to the adjacent, AB over AC, good? This is the conclusion, and we'll use this rule once we've solved and do our problems. So today's problems are
I'm gonna
here.
thank you for letting me know.
Good. Thank you very much. So follow Jaden. So she has drawn the picture, the figure, and looks like angle is bisecting. So she has taken those as y, EF as y, made her life easier so that she doesn't have to say which EF and blah 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 blah, right? same thing. So that makes life easier, right? And she can always do that. So what Jaden has done, he has taken this one. You know that this guy, guys, this guy should be in the numerator, and if you put that with x minus 1, this adjacent is this, which was given as 4EF. She has taken this one as y and 4y, right? So now this one adjacent is 4y over y, cancels out 4, then extreme or cross multiplication, and you guys did the algebra. So, and then addition property, okay, and then division property of equality, and x is 6. Everybody good with that? Give me a thumbs up. Okay, great.